Welcome to Secondary Chemistry. Today we are going to introduce a new series to you about organic chemistry. Organic chemistry is quite a big topic in IGCSE and GCSE chemistry, and it's usually put to the end because it's meant to be the most complicated part of your chemistry studies. And today we will start with an introduction to organic chemistry, which will lay some foundations and be most of the time revision of things you could or should already know. Our outline for today is to cover what is organic chemistry, the bonding of chemistry, and the so-called displayed formula, what it is and how it can be used. What is organic chemistry? Organic chemistry is one of three branches of chemistry. We have inorganic chemistry that deals with all the elements except carbon. And then we have organic chemistry, which exactly focuses on the element of carbon only. And we have physical chemistry, which works with physical methods in chemistry. And in organic chemistry, we know around 40 million compounds currently, whereas in inorganic chemistry, only 100,000 inorganic compounds are known. So we have much more organic compounds than inorganic compounds. This raises the question of why carbon is able to produce such a variety of compounds. And this, of course, on a molecular level has to do with the type of bonding that carbon is up to. That's what I want to look at with you next, the bonding of carbon. The three major types of bonding in chemistry are metallic bonding, ionic bonding, and covalent bonding. Is it possible for carbon to do metallic bonding? Well, probably not, because carbon is a nonmetal. Is it possible for carbon to do ionic bonding? And that's what we can look at the bottom of this page. For ionic bonding, carbon would have to be able to form stable ions. So either cations or anions. Now a carbon atom has exactly 4 outer shell electrons. So it could behave like nonmetals and accept electrons until it has 8 outer shell electrons, so the noble gas configuration like neon. But accepting 4 electrons is very difficult because the 4 negative extra charges are simply too much for the carbon atom, and a theoretically 4 times negatively charged ion cannot be stable because the positively charged nucleus cannot hold the 4 extra electrons. The repelling forces are far too strong within the electronic shell. But could a carbon atom behave like a metal atom and submit outer shell electrons and empty the shell to have the next shell being full? In this scenario, a carbon atom would have to lose 4 electrons, and that's also quite hard because you have to think a carbon atom is neutral in the beginning, electrically neutral, and then you remove from a neutral atom 1 negative charge, namely an electron. So the carbon atom remains 1 times positively charged and turns into an ion thus. And then you have to remove further and more electrons. But the particle from which you want to remove the electrons is already positively charged. So it's even harder to remove more negative charge. And that's why you can't even reach a state where you make carbon atoms lose 4 electrons. We conclude that carbon cannot form stable ions, and that's why carbon can't bond ionically. In the end, it has to be that carbon bonds covalently. And yeah, we want to look at covalent bonding right now and how it explains the variety of compounds that are able to be formed by the element of carbon. Here you see a dot and cross diagram. Maybe you're already familiar with this type of representation. And in covalent bonding, the main point is that electrons are shared between two atoms for both atoms to gain a full outer shell and achieve the noble gas configuration. So hydrogen atoms, for example, they want to have a full outer shell with 2 electrons, then they are similar in their electronic configuration like helium. And carbon wants to have 8 outer shell electrons. That's also a noble gas configuration, namely the electronic configuration of neon. And yes, here on the left side, you can see how covalent bonding works. So the carbon atom has 4 electrons. They are represented by crosses. And every hydrogen atom has 1 outer shell electron, and it's represented by a dot. And here, if you have a look at the encircled area, we have the situation that the carbon atom shares its electron with the hydrogen atom and vice versa. And that happens 4 times in this molecule. And then the carbon atom assumes that all the electrons belong to itself. So then carbon counts 8 electrons and achieves the noble gas configuration in this way. And every hydrogen atom considers the shared electrons to be their own. So every hydrogen atom thinks that it has got 2 outer shell electrons and thus also achieves the noble gas configuration. And yeah, the term shared pair of electrons is something to remember. A shared pair of electrons is actually what makes the bond in between 2 atoms. So sometimes one might think, well, what is actually a bond? A bond is something weird, something abstract. Maybe it's a stick between 2 atoms which makes them hold together. But in fact, a chemical bond is nothing else than a shared pair of electrons. The molecule that is depicted on the left-hand side is the simplest organic molecule in organic chemistry. It's called methane, and we will learn more about methane in later videos. For now, I just want to mention that methane is a greenhouse gas. This means it contributes to the greenhouse effect, and it contributes much more than carbon dioxide, for example. And methane is, for instance, emitted by cows. I also want to revise the meaning of molecular formula. The molecular formula of methane is CH4, and this tells you that within one molecule of the substance methane, we have 1 carbon atom bonded to 4 hydrogen atoms. In the end of this video, I want to introduce the term displayed formula. A displayed formula shows all the atoms and all the bonds. And we want to have a look on how we can transfer a very detailed representation of an atom, like here, into a displayed formula, like here. And in a displayed formula, the element symbol, so in our case the O, contains the nucleus and all the inner shell electrons. So all this is put into the element symbol. And then all the other stuff around the element symbol represents what is going on in the outer shell. And in the outer shell of an oxygen atom, we have here a pair of electrons, so 2 electrons, and they are represented as a dash. And a single electron, as we can find it here, is represented by a dot. And on the right hand side, you can see the displayed formula of methane. We have seen the dot and cross diagram earlier, and here is the corresponding displayed formula. So what we can see here, the dash represents our shared pair of electrons, and it represents 2 electrons that are in between the carbon atom and this hydrogen atom. Okay, I hope you got what a displayed formula is and also the other stuff that was covered in this video. Thank you for watching, and I'm looking forward to see you in the next video.